So far we've looked at very simple commands: a skip, an abort, an assignment to a simple variable. Obviously that's not a very interesting program. So let's see what happens if we start putting multiple commands together. In other words, what if we start composing commands to create more complex programs? Okay, so here we have a program that consists of two commands, S0 and S1. And S0 and S1 eventually can be as complex as you want them to be. How does it work? Well, you execute command 0 and then you execute command 1. Now, sometimes we may not want to write these on separate lines, so a more concise way of writing this is S0, S1, and then to know where one command stops and the next one starts, we put a semicolon in the middle of it. So the question we then ask ourselves is, when is the Hort triple, Q, command S0 followed by S1, are correct? Well, it's when Q implies the weakest precondition of the composed command S0, S1, leaving you in a state where R is true. And that means we have to define the weakest precondition of S0 composed with S1. Well, let's think about this for a second. Let's consider the program where we have them written above each other. What do we know? Well, we know that if we want to end up in a state where R is true, then just before S1 is executed, the weakest precondition of S1 leaving you in a state where R is true must be true. S0 has to leave you in a state where that weakest precondition is true. So what does that mean? Well, that means that before S0 is executed, the weakest precondition of S0, leaving you in a state where the weakest precondition of S1 is leaving you in a state where R must be true. So, whenever you say must be true, that means that that is the weakest predicate that describes a state that you must be in. And what that means is that we can take that to be the weakest precondition of the composed command S0, S1 if you want to finish in a finite amount of time in a state where R is true. So that's the definition. Now we can obviously generalize this. We can compose three commands, and what that means is that the first two commands must leave you in a state where the weakest precondition for the third command holds, and then you can peel that off and you find that it's the weakest precondition of S0 leaving you in a state where the weakest precondition of S1 leaving you in a state where the weakest precondition of S2 leaves you in a state where R is true. Or you can peel it in the opposite direction. And obviously you can generalize this to the composition of n commands. So, we've just figured out how to define the weakest precondition of a composed command. And what you're going to do for the rest of this unit is get some practice with this.